Good afternoon, everyone. I would like to welcome a reviewer of our project, Shobha ma'am, Santosh sir, and guide Shruti ma'am. I would like to start our presentation by introducing ourselves first. My name is Veena Shri from 7th C.
My name is Sanjana from 7th B.
I'm Chaitra from 7B.
I'm Soumya from 7B.
The title of our project is Camouflaged Animal Detection. Now let's begin with the introduction. Camouflage is the ability of prey to hide from predators by changing their body pattern, texture, and coloration as per the environment. Camouflaged animal detection is a method used to detect foreground animal hidden in the background image. Organisms use camouflage to mask their location, identity, and movement. These allow prey to avoid predators and for predators to sneak up on prey. Our aim is to segment camouflaged animal hiding in the environment, which is challenging due to the similar appearance of animal and their surroundings. The problem statement of our project is to detecting the camouflaged animal by using image processing method such as OpenCV method to analyzing and detecting the animal.
Objectives. The main objective of the project is to detect the camouflaged animal by using OpenCV technique. Inputting the image containing camouflaged animal, performing the pre-processing to remove the noise and resizing it. By changing the contraction and by image saturation, we can easily find the animal which is hiding in its background. Next, existing system. Existing work on this problem has been done based on biological characteristics of the animals. Some articles reviews the existing camouflage animal detection and techniques using computer vision algorithms. These algorithms are used in detecting the animals by using search and identification techniques. Moving to proposed system. In proposed system, the users can detect the animals accurately. It will also provide easy way to upload the images to the system by using computer vision methods. Then it gives the result. It gives better experience to the users while detecting animals by saturation and by using the gray level scalings in this technique.
In literature survey, we have studied some of the papers related to camouflaged animal detection. Paper 1, title Accurate Camouflaged Object Detection via Mixed Convolution and Interactive Fusion of 2021. In this paper, the camouflaged object detection is mainly determined by two factors. First one, significant large field. Second one, an effective fusion strategy. They propose a novel deep learning basic COD approach which integrates the large field and effective features from a backbone network.
Paper 2, title Deep Texture Aware Features for Camouflaged Object Detection in 2021. This paper presents to amplify the subtle texture between camouflaged object and the background for camouflaged object detection by formulating multiple texture-aware refinement modules to learn the texture-aware features in deep convolutions neural network. We evaluate our network on the benchmark dataset for camouflaged object detection, both quantitatively and qualitatively. Our key idea is to amplify the texture difference between camouflaged object and their surroundings, thus benefiting to identify camouflaged objects from the background.
Paper 3. Title of the paper is Context-Aware Cross-Level Fusion Network for Camouflaged Object Detection. In this paper, we propose a context-aware module which exploits global context information from the fused features. Camouflaged animal detection is a challenging task due to the low boundary contracts between animals and its surroundings. Due to the purpose of survival, wild animals have developed rich camouflage abilities. In recent years, camouflage has attracted increasing research from the computer vision community. There are natural differences among different types of camouflaged objects. Besides, the size of similar camouflaged objects may also vary greatly due to the observation distance and their relative location to the surrounding environment. In other words, for a captured image with camouflaged animals, the proportion of the camouflaged animals often varies.
Paper 4. The title is Camouflaged Object Segmentation with Distraction Mining. In this paper, they develop a bio-inspired framework termed Positioning and Focus Network, which mimics the process of predation in nature. Specifically, Positioning and Focus Network contain two key modules, Positioning Module and Focus Module. Positioning module is designed to mimic the detection process in predation for positioning the potential target objects from a global perspective. In focus module, they develop a novel distraction mining strategy for distraction discovery and removal to benefit the performance for estimation. Next, paper 5. The title is Mutual Graph Learning for Camouflaged Object Detection. In this paper presents the design a novel mutual graph learning model which generalizes the idea of conventional mutual learning from regular grids to the graph domain. Specifically, mutual graph learning decouples an image into two tasks, specific features maps, one for roughly locating the target and the other for accurately capturing boundary details. Paper 6. The title of the paper is Camouflaged Object Detection. In this paper, they present a comprehensive study on a new task named Camouflaged Object Detection, which aims to identify objects that are seamlessly embedded in their surroundings. To address the issue, they elaborately collect a novel dataset called Code 10K, which compresses the 10,000 images covering camouflaged objects in various natural scenes over 78 object categories. In addition, they develop a simple but effective framework for camouflage object detection termed Search and Identification Network. The Search Identification Network is implemented in PyTorch and trained with the ADAM optimizer. Let's get into initial design. In initial design, we use methodology of capturing the image from any camera or sensors, then pre-processing the image to remove the noise, then classify the image from the background using gray level scaling techniques to detect the animal accurately. Finally, output the identified animal.
Survey findings. A novel deep learning based COD approach can integrate the large receptive field and effective features fusion into a unified framework. Mutual graph learning develops an image into two tasks, specific feature maps and the mutual benefits by recurrently reasoning their high order relations through graphs. The texture aware refinement module computes the covariance matrices of features response to extract the texture information, design an affinite loss to learn and help to separate the texture between camouflaged objects and the background, adopts a boundary consistency. in ASPP model used to enhance the image feature of camouflaged object and then connect the parallel decodes module get the global map by using the graph reversal block. Next. Future enhancement. In future enhancement, real-time camouflaged animal detection by use of to achieve faster and more accurate image detection. The design and implement a image processing techniques based on detection, which is a software. Next, reference. Hybrid task cascade for instance segmentations in CVPR in 2019, graph-based global reasoning network in CVPR in June 2019, parallel reverse attention network for polyp segmentation international conference on medical image computing and computer assistance intervention in 2020, camouflaged object detection in proceeding of the IEEE Conference on Computer Vision and Pattern Recognition in 2020. Thank you.